Let's look at some tangent theorems now. What we want to have a look at, the first one is that if we got tangents to a circle. Now, remember, a tangent is a line that is drawn, and it is given. We've got a situation where it's drawn to a circle and touches the circle at one point. So that's what a tangent does. It touches a curve at one point. Now, when we've got that in on a circle there, our radius becomes perpendicular to the tangent itself. So whenever the point is, we hit it perpendicular there. So the proof there is not really like explicit as such, but we can read in the way that if we look at what we've got here with a tangent to a curve, and OB would be the radius, the shortest distance between the 2 points is the perpendicular distance, and B is always on the circle, C is outside the circle, and so OC here is always going to be greater than OB. So OB is always less than OC. So OB must be the shortest distance, so it has to be perpendicular. Because B is always the shortest distance, so the perpendicular distance is always the shortest distance there. So that's what we're looking at with that rule. So we can see in our circle, when we've got this one here, that we've got radii and two tangents to the circle. And you can see that no matter where I move them, the two tangents are always perpendicular to the radii that we've got there. So it's always staying at alpha and beta is equal to 90 there. So that's what we're looking at with that one. What this does bring in for us as well is another rule, and this is one where with the two tangents, if we have two tangents from a point, so from any external point C, and we can move that point around C, so it can be anywhere, it's gonna always have two tangents from any point outside the circle. Now, what if hopefully you're looking at and noticing that the two distances, CE or EC and CD, are exactly the same. No matter where I move them, our radii stay the same. So I can get it really close, so our distances get smaller, and I can move it farther out, and our distances get larger, but they stay the same every time. So there's the theorem we want to deal with there. And the theorem we want is to look at this one here. Two tangents are drawn to a circle from an external point, then they're equal. So how do we prove that? So we want to prove here that AB and AC are equal. So we've got our two radii, OB, OC. So we draw those up in our circle. We know that the tangent and the radius is perpendicular, so we can say that OCA and OBA are both 90 degrees, so they're equal. We know that OB and OC are equal because they're radii, and we construct a line from O to A. We can get two right-angled triangles there with OA being common. Now that forms our hypotenuse opposite our right angle with another side equal. Then these two triangles must be congruent. So if they're two congruent by right angle, hypotenuse and side, then AB and AC are equal because they're corresponding sides in congruent triangles. So there's our first rule. Well, our second rule. We know that from what we've done here, our radii are perpendicular to our tangents, and tangents from a given point are always equal to either side of the circle there. So there's our theorem. Remember how it is expressed, so you can use it in your proofs. But we can say straight away that those two are always going to be equal.